So how do you know if the distribution is normal? You need to know if the distribution is normal before that you can do any of those normal probability calculations that we've done in the previous section. Like using norm CDF on your calculator, or if you're using old school z-tables, anything with z-scores and finding these probabilities, you have to know if it's normal in distribution. So there's 4 ways that you can find out. And we're going to walk through these 4, and hopefully that'll give you the tools you need to know before you start doing calculations. So the first way, obviously, make a display of the distribution, a stem plot, a dot plot, or a histogram, and look at the shape. Okay, so notice I didn't say box plot because box plot's not a real good indicator of shape. So don't go there, but make stem plot, dot plot, or histogram. That can help you. Number 2, you can use the summary statistics to see the relationship between the mean and the median. Because remember, mean and median will be close together if it's normal in shape. And number 3, you can check that empirical rule, the 68, 95, 99.7 rule. If it makes sense with the data, that's a good indicator that it is normal. And then another option is to create what we call a normal probability plot to check for a linear pattern in the distribution. Now, you don't have to do all 4 all the time. It just depends on what they give you. Sometimes they give you summary statistics, sometimes they give you all the data, sometimes they don't give you anything but a mean and a standard deviation. So it just depends on what the question is giving you as to which method you're going to use to determine normality. So we're going to walk through each one of these in this presentation. All right, so let's use this example throughout the slideshow just to kind of show you what we can do. The measurements listed below describe the usable capacity in cubic feet of a sample of 36 side-by-side refrigerators. Are the data close to normal? So here's the cubic feet usable capacity of these guys. So we need to know, is it normal? So the first option is to make a display. And so we made a stem plot. And I can look at this and go, okay, it looks pretty symmetric and it's pretty much bell-shaped. And that would be a really good indicator of a normal distribution. And that would suffice. You just have to show, you look, it's normal, there's no outliers. It's a pretty good indicator that this is normal enough to proceed with using z-tables or the norm CDF function. Okay, so for the second option, you can use the summary statistics to see the relationship between the mean and the median, which does indicate shape. So if the mean of my sample, x bar, is 15.8 cubic feet, that's good, but I need median. So I go to my calculator and I find the median in the 5-number summary, right there, 15.9. So notice these values are extremely close together. They're not perfect, but in stats, nothing is ever completely perfect. But these are close enough to indicate that this is approximately normal. So we would say this is an indicator the distribution of the refrigerator capacities is indeed symmetric in shape and normal enough to proceed using norm CDF. All right, so the third way we can look at this data and determine if it's normal enough to proceed is check it with the empirical rule, the 68, 95, 99.7 rule, and see if it makes sense. So what I mean by that is, does it make sense that values 1, 2, and 3 standard deviations from the mean are logical in the context of the question? So revisit this. The mean of our sample was 15.84. The standard deviation of our sample, we put it in the calculator, was 1.241. All right, so if I take the mean and I add 1 standard deviation, I get 17.8 whatever, or 0. If I subtract 1 standard deviation, I get 14.6. So would those be legit cubic feet capacities for refrigerators? Yeah, that makes sense. That could be a possibility. And then I ask myself, okay, how many of the 36 fall within that range? Well, if I counted, 24 out of 36, so that's about 67%. Pretty close to the 68% the rule dictates. So then I try it for the next standard deviation. I'm going to add 2 standard deviations to the mean. I'm going to subtract 2 standard deviations from the mean. That gives me this range of values, 13.36, 18.32 cubic feet. And again, I look at my set of data. And how many of those pieces of data fall within that range? 34 of them out of 36. So that's about 94%. Again, it's very close to the 95% that the rule tells us. And then lastly, if I do 3 standard deviations, that brings me to 12.19 or 119 and then 19.565. Again, I look at my data. How much of my data falls within that range? Well, all of them do. So that's 100%. So because my percentages are so close to the empirical rule, remember, they're not going to be exact. Sometimes they might be, but you have to have a large data set. If they're close, like this is, that tells us that the distribution is approximately normal. So this is a more tedious way of finding out, but it is one way of doing it, and you might need it every once in a while. Now the last option for showing normality is something we call normal probability plots. It's another graphical distribution or display of a distribution. And you can tell, the whole purpose of it is to tell if the distribution is normal, basically. And so it's a great tool to look at really quickly and know if it's normal. So here's a tip. They're not really included on the APA topic outline. However, they are very useful for assessing normality. You can use them on the AP exam if you wish. Just make sure you know what you're looking for. So it's occasionally going to show up. It's not a big deal, but I'm just going to introduce you to it and what you're looking for. So the first thing you would do if you were creating a normal probability plot is to put your data in list 1. By the way, I put all the calculator steps on the last slide, and it's also in your notes. But put all your data in list 1, and then we will go to the StatPlot menu. So this is what the StatPlot menu will look like. You'll have to turn it on. It may default to off. And then under Type, there's all your display options. This very last one right here is the normal probability plot. So the calculator is going to calculate the z-scores, it's going to graph it, all that stuff. Your data list is in list 1, and everything else stays the same. Data axis is on the x, so you're going to put your data on the x-axis. So when you do zoom 9 and you go to the graph, this is what you would see. You can see that each data point is corresponding to its z-score. It's not labeled, the axes aren't labeled, but that's what's happening here. What you're looking for is for the distribution to have a linear pattern in their z-scores. So when you interpret this kind of thing, don't just say is linear. Say something like this. Distribution of usable capacity in side-by-side refrigerators is approximately normal because the normal probability plot is fairly linear. If you say it is linear, that's a stats no-no. You can't say that because I don't know what it is. You have to tell me it's the distribution of whatever the context is. In this case, the usable capacity of side-by-side refrigerators. Because the normal probability plot is linear. Okay? You can't just say it. Be careful with your pronouns. Make sure you've clarified them when you're writing interpretations. Right? And here's the calculator keystrokes in your notes. You also have these, but this is how I got to that if you want to play around with it. But that's how you find a normal probability plot and how you interpret it.